Hi everyone, myself Dr. Bharat, Assistant Professor from Kristo Jayanti College, Bangalore. In statistics for managerial division, one of the important concepts is the bivariate data analysis. In bivariate data analysis, we are using two data set to identify the nature and the relationship and the effect of the other. We are going to discuss the basics about the bivariate data analysis. What are the different types of bivariate data analysis? In bivariate data analysis, there are two important concepts that is the correlation and the regression. So first, in the first video, I'm going to discuss about the correlation, and the second video, I'm going to discuss about the regression. So the contents of the correlation is what is exactly the correlation, why the correlation analysis we are using in statistics or in business, and what are the different type of correlation, and what are the methods of calculating the correlation between two variables. That is the Carl Pearson coefficient of correlation and the Spearman correlation. These are the two important methods of correlation. So I'm going to give you the detailed steps about these two methods. So first of all, what exactly correlation? Why we are using this correlation? Mainly because to measure the relationship between two variables. So measure in terms of what direction the correlation, whether it's a positive correlation or a negative correlation, and which direction it is going. Whether it's they are going in the same direction or the opposite direction, or there is no correlation. So to know these, the relation between two variables, we are using the correlation analysis. Correlation analysis just gives you what kind of direction and strength between the two variables. So what are the uses of correlation analysis? So mainly correlation uses to measuring the extent of covariance between the two variables. To identify the what extent the covariance between two variables, the correlation will help us to know. To identify a relationship between two variables, we are using the correlation. So what kind of relationship they have and how strong it is. So at the end of the this correlation analysis, you'll come to know what is the relationship and which direction it is moving. We can come to know with the help of correlation, so we can estimate the future value of the variable. So why we are using the another importance of these correlation analysis, we can these using these correlation values, we can predict the values. In business, you're normally using these correlation analysis. They are using to estimate the what futures cost, what is the sales, and what is the price. Other purpose they are using these correlation analysis. So mainly correlation analysis, what kind of relationship between two variables we can easily identify. So, for example, is there any relationship between a person's salary and the age? So, is there any relationship between salary and the age? So, there are two variables. One is salary, another one is age, person's age. So, age increases, whether salary also increases. If age is very less and salary also very less, will come to know. So in this scatter plot, every single point is a person. So we are calculating a single person salary and their age. So age increases, the salary of the persons also increases. So there is a positive correlation indicates. So types of correlation normally, so we have broadly three category. One is positive correlation, negative correlation, and no correlation. When positive correlation occurs, when the value, the R value, the correlation value is between 0 to 1, then it's a positive correlation. That means both both variables For example, x increases, y also increases. X is a one variable or one series, y is one variable or one series. X increases, y also increases. That is a positive correlation. A negative correlation indicates when one variable decreases, another variable increases. There is a opposite um, opposite direction, inverse relationship. So one variable increases, another variable decreases. So the R value is negative between 0 to minus 1. In that case, one variable increases, the other variable decreases. The other one, no correlation. When the correlation value exactly zero, when correlation exactly zero or near to zero, then so there is no correlation between two variables. So there are two methods of calculating the correlation method. One is we call Pearson coefficient of correlation, and the one is Pearson rank correlation. These are the two important methods to calculate the correlation. So what are the steps to calculate the Carl Pearson coefficient of correlation? So the now usually R value is a correlation equals sum of x and y, two variables x and y divided by square root of sigma x square and sigma y square. So how to calculate the sigma x square and sigma y square? So first we need to take the deviation from the mean value, then square that value, square deviation, you will get a sum of square deviation of x value and square deviation of y value. This is a basic formula. So this is based on this formula is based on the mean value. So we are taking the deviation from the mean. If we are taking deviation from assumed mean, so this is the formula. So correlation equals n means the number of observations in the x value and y value, sum of deviation of y and deviation of x and deviation of y minus sum of deviation of x and sum of deviation of y divided by square root of n multiplied by sum of deviation of x squared minus sum of deviation of x whole square. So this is for x and this is for y. So when we are using assuming, so this is a formula we need to use. The other formula, if in the problem standard deviation is given, then directly if they are given standard deviation, we calculate the correlation value. So R value equals sum of xy divided by n multiplied by standard deviation of x and standard deviation of y. If sum of square of deviation from mean is given, so in some problem, they directly calculate the sum of deviation from mean of x and y. In that case, how to calculate the correlation? Correlation equals sum of x and y divided by square root of sigma x squared multiplied by sum of square root of sum of y square. So when it comes to Spearman rank correlation, so Spearman rank correlation is now this method is given by British psychologist Charles Edward Spearman in 1940. So the method to calculate the coefficient of correlation between two set of variables, which is not quantifiable but ranked. So when we are using this, when two persons or two series, for example, there is a one event is going on, one event. So there are two judges are sitting in that event. So there are two judges sitting in the event. For example, judge one and judge two. So these are the two variables. Judge one is a one series, judge two is a one series. So we want to know both judge one and judge two are giving the same ranks or different ranks. To quantify that, so we are using Spearman rank correlation coefficient. So the formula is the rank correlation coefficient equals 1 minus 6 is the constant. So multiplied by sum of deviation square divided by n cube minus n. So now, so in rank correlation, we have three types. Normally, when ranks are not given, when ranks are given, when ranks are tied or repeated ranks. When ranks, same formula you can apply. When ranks are not given, so we need to give the ranks. So you can give highest number has a rank one or lowest number has a rank one. So according to the based on the data, so you can give the ranks. The second one, when ranks are not given, you need to give the ranks. When ranks are given directly, so directly you can take the deviation from rank 1 and rank 2 and calculate the correlation. When ranks are tied or repeated ranks, in that case, so first identify the lowest one and give the ranks. And if there is any, how many times it is repeated, you can use the same formula and find out the is there any significant difference between the two variables. Thank you so much.